Welcome back to our intermediate algebra course, and we are talking about rational expressions. The challenge is about fractions or rational expressions. Look, 1/2 is 1/3 of it. What is it? What is the answer? And the hint is, I'm pretty sure the answer will be a fraction. So look at the picture. The picture also helps understand and find the answer to this riddle. 1/2 is 1/3 of it. What is it? We are covering today's section 6.2, adding and subtracting rational expressions. First, let's see the easiest situation when we have the same denominator, a common denominator. Okay, so let's go straight to the example. If we have the same denominator, you can remember what we do if we work with numbers. Let's say 5 over 3 plus 1 over 3. If the denominator is the same, we just repeat the denominator, 3, and we're going to add or subtract the numerators. In this case, 5 plus 1 equals 6 over 3. Don't forget, after you find the answer, check if you can simplify, because this might not be the final answer. 6 divided by 3, 2. This is the final answer. Right? So pretty easy. Repeat the numerator. What about if we have, instead of numbers, if we have letters? Like this example. Same thing. The same thing. Draw here the fraction bar, and then you're going to have 2p plus 7. Repeat the denominator, and you will combine, add or subtract the numerators. 4p minus 3 plus 3p plus 8. Simplify, that's going to be the answer, but in this case we have to check if we can combine like terms. Look, 4p plus 3p equals 7p. Negative 3 plus 8, positive 5 over 2p plus 7. And there's no more way of simplifying. That's the final answer. Subtract. If we have the same denominator, look, the same thing. Fraction bar, repeat the denominator, y minus 2, and combine the numerators, 8y minus 16. Next step, always simplify if possible. We can, look, 8, 16. There is a greatest common factor that can factor out. 8 times y minus 2 over y minus 2. And finally, we can cancel if we have the same factor on the top, on the bottom. And the answer is 8. Final answer, simplest answer possible, equals 8. Okay. Subtract. Again, this is going to be kind of interesting, because look, the denominator is y squared plus 3y minus 10. The numerator, 3y minus 6. Okay, that's the answer, not the final answer. To simplify, we have to factor out everything possible on the top. We have to factor out everything that's possible on the bottom, and find factors that we can simplify, canceling out. All right, on the top, I can see pretty clear the greatest common factor. 3 and 6, we can we can put here in front of the parentheses 3 multiplied by y minus 2, right? 3 times y, 3y, 3 times negative 2, negative 6, perfect. On the bottom, what should we do on the bottom? Look, we have, that's a trinomial, it's not a perfect square, but we can guess two numbers that multiplied is equals to negative 10. If you add is equals positive 3. What are the numbers that you think that can multiply this negative 10? Well, 10, 1 times 10, 2 times 5, that's it, right? And the ones that we can combine to make positive 3, we need 2 and negative 5. 2 times negative 5, negative 10. Oops, the other way around. Negative 2 and positive 5. Negative 2 plus 5, positive 3. Okay. Oops, this is y. Y minus 2, y plus 5. Perfect, because that allows us to simplify y minus 2 with y minus 2. The final answer will be 3 over y plus 5. Okay, moving on to the next objective, identifying the least common denominator. This is one step before we work with fractions with different denominators. We know how to add, subtract if they have the same denominator. What about when they have different denominators? And the answer is we need to find the least common denominator. When we work with numbers, it's kind of easy because you have, let's say, 6 denominators. 1 over 6 and 1 over, let's say, 9. 6 is 2 times 3 if you break down into prime numbers, right? 6, 2 times 3. 9 is 3 times 3. The unique factors are the factors that will not repeat. So we have 2, and we're going to have 3 and 3 repeats. So we're going to exclude if they repeat, and we have another 3 that doesn't repeat. The least common denominator is equals to 2 times 3 times 3. That's 18. Because 18 is the least number that you can divide by 6. 18 divided by 6 is 3. And at the same time, you can divide by 9. 18 divided by 9, 2. That's the reason we call least common denominator. That's what we're going to do even if we have expressions with variables. We will factor out and find unique factors. Okay, so we're going to skip this because we're going to come back later to this. Look at the denominators. We have x squared plus 4x plus 3. X squared plus 10x plus 21. We will use the guessing methods. Find two numbers that multiplied is equals to 3. If you add, equals to 4. Of course, that's an easy one. 1 times 3, 3. 1 plus 3, 4. Those are the two numbers. Now, this other denominator. Find two numbers that multiplied is equals to 21, and if you add is equals to 10. It's not so hard. We can think about 3 as well, and 7. 3 times 7, 21. 3 plus 7, 10. Nice. Now compare these two factors with those other two factors. We need only the unique factors. x1, is it unique? is not repeated on the other one, so it's unique. X plus 1. That's the least common denominator. X plus 3 is unique. Look, we have a repeat here, so we don't need to repeat. Just one time x plus 3. And x plus 7. This is the least common denominator. Another example. Let's go back to this one. I don't like this example, but let me show anyways. If we want to break down 6y, we can write as 2 times 3 times y, okay? So 3 factors. If we want to break down 4y plus 21, look, we cannot break down this plus. This is going to be only one factor. But we might be able to find a greatest common factor between 4 and 12. 4, yes, times y plus 12. And we can break 4 as 2 times y plus 12. Compare 2 times 3 times y, 2 times 2 times y plus 12. I know, yes, 2 and 2, they are repeated, so we just need it once. Don't. The other 2 is unique, okay? Then we have 3, and the tricky part, we have y, and we have y plus 12. You need to know that those are 2 different factors, because we don't know the value of y. But we know, for instance, let's say y is equals to 1. So this factor would be 1, and this factor will be 1 plus 12, 13. So they are different factors. We cannot say they are each one of those factors is unique. So times y plus 12. That's the least common denominator. Let's go back to something that might be a bit more clear. Compare only the bottom, the denominators, factor out everything that you can. In this case, look, I think we can factor out 2 things. First, factor out the greatest common factor 5, and then factor out, because x squared minus 1 is difference of 2 squares. That's going to be 5 times x plus 1 times x minus 1. Completely factored. Now the next one. Guess. Think about 2 numbers that multiplied is equals to 1. If you add is equals to negative 2. Well, we can think x minus 1 times x minus 1. Right? Least common denominator. Well, 5 is a unique factor. X plus 1 is not repeated, so yes, is a unique factor. X minus 1 is repeated, so you're going to use just 1. And we're going to have another x minus 1 that's also unique. Okay, this is the least common denominator. The whole point of finding the least common denominator is to get an expression that if you divide by the first denominator, you can simplify. If you divide by the second denominator, you can simplify, and you're going to end up with some kind of an expression. Okay, for instance, if you divide this least common denominator by 5x squared minus 5, it will cancel out 5, it will cancel out x plus 1, it will cancel out x minus 1. We always keep something, right? We simplify everything, but we keep an expression. Sometimes we keep just one We will see more about it later. And that's a tricky one. Look, find the least common denominator of the rational expression 1 over x minus 3, 2 over 3 minus x. The only thing that we can factor out, we don't have actually anything to factor out, but we can factor out -1. Factor only on the one on the right. Okay, so let's factor out here -1. -1 times -3 plus x. This is the same thing as -1 times x minus 3. Now we have the same factor. The least common denominator is actually x minus 3. That's all. Next objective, adding and subtracting rational expressions with unlike denominators. The whole work we've done here to finding the least common denominator will pay off because we will use now to add or subtract fractions that have different denominators. The first thing you always will do when you have different denominators is finding the least common denominator. Let's find here on the bottom. We have, it's between, the denominators are 7a and 6a, okay? What are the unique factors? We have 7 times a, we have 6 times a, oops, 6 times a. So the unique factors are 7 is a unique factor, 6 is a unique factor, and a is repeated. You don't need to repeat another unique factor. Great. Now we will use, the next step is very important. We will change each one of the denominators by multiplying by the factor that's missing. Look, 7a, let me write down here 7a. We have 7, we have a, but we don't have 6, right? So multiply by 6 is the factor that's missing. But you have to multiply also on the top, so you keep the same fraction, the same ratio. On the next one, you do the same thing. The next fraction is 8 over 6a. Now we have 6, we have a, we don't have 7. 7, 7. So multiply. When we change the denominators by multiplying by the factor that's missing, when we compare with the least common denominator, we make all the denominators the same, equals as the least common denominator, 7 times 6 times a. And we can now combine, simply combine the numerators. Well, 6 times 15, I think is 90. 7 times 8, it's probably 56. And 7 times 6, 42. A. 1, 4, 6. This is the answer, not the final answer. We still can simplify. At least we can divide both numerator and denominator by 2, and then we get 73 over 21a. Yes, now this is the final answer. Another example, subtract 5 over 2x minus 6 minus 3 over 6 minus 2x. Be careful, that's a tricky question. Look, compare the denominators. Yeah, they kind of look alike, but they are switched, right? If you factor out from just one, of these two denominators, you factor out -1. Then you're going to have 2x minus 6. They are actually the same denominator, only with the -1 factor that we can factor out. Okay, now write as 2x minus 6, 5 over 2x minus 6, minus 3 over -1, 2x minus 6. We can combine, because we have negative divided by negative, negative divided by negative is positive. So this is the same thing as, remember, negative divided by negative positive, so 5 plus 3. And 5 plus 3, 8, 2x minus 6. Think, is there anything we can simplify? We can factor out and simplify? Yes. Yes. 2x minus 3. And another thing we can do is divide 8 divided by 2, 4. 4 over x minus 3 is going to be the final answer. Interesting example. Look, x squared minus x minus 6 is one of the denominators. And the other denominator is x squared plus 5x plus 6. We have to break down. We have to factor out each one of the denominators. The guessing method, still, I think you're going to use a lot the guessing method at this very beginning, because I think it's easy to understand and to apply, right? Two numbers that multiplied is equals to -6. If you add is -1. So think maybe x. If you're not sure, you write down all the numbers that multiplied is equals to 6 times 3. That's all. And of course, we can combine 2 and 3. -3 x plus 2. -3 plus 2, -1. -3 times 2, -6. Great. Another one. Two numbers that multiplied is equals to 6. And if you add is equals to 5. X plus 3, x plus 2. Perfect. The least common denominator, let me write here on the bottom. Only unique factors. X minus 3 is a unique factor. X plus 2 is repeated, so only once. And x plus 3. Write down, I will write down here. Well, if we break, I'm going to use the denominator that's broke down into factors. Okay? Plus x over x plus 3, x plus 2. Oops, sorry. X plus 2. What's missing on the first fraction? If we compare the denominator with the least common denominator, we have x minus 3, we have x plus 2. It's missing x plus 3. So multiply on the top, on the bottom by x plus 3. The next fraction, we have on the denominator x plus 3, x plus 2, but we don't have x minus 3. So multiply x minus 3, x minus 3. Great. Simplify. The first thing we have to do is apply distributive property on the denominators. Look, okay. And we will have, we can write now this under the same the same denominator. See, both are the same as the least common denominator. So this is going to be our denominator. And 4 times x plus 4 times 3, 12, plus x times x, x squared, and x times negative 3, negative 3x. Finally, I think we can combine some like terms and just don't need to multiply the denominator, keep it as factors. On the top, we will have x squared, 4x minus 3x plus x plus 12. I don't see any way of simplifying anymore, so this is going to be the final answer. In the next example, we have addition, subtraction, we have 3 fractions. Not a problem. It's the same procedure. We need to find the least common denominator. So let me write down here in the bottom, least common denominator is going to be equals to, here we have just one factor, x minus 1, this denominator. The second denominator we have here, x squared minus 1 is difference of 2 squares. We can write as x plus 1 times x minus 1. And finally, the last denominator, x plus 1. Find the unique factors. Unique. X plus 1, x minus 1 is repeated. So don't repeat. X plus 1 is also repeated in different denominators. Don't repeat. Oh. The least common denominator will be x minus 1 times x plus 1. I will repeat this expression here on the bottom, just giving some space because we will complete with the missing factors. X plus 1. Instead of x squared minus 1, I'm going to write down the resulting of the factorization, the breaking it down, x plus 1. Nice. First denominator, what's missing? Look, compare with the least common denominator, it's missing x plus 1. Multiply by x plus 1 on the top, on the bottom. Second denominator, nothing is missing, it's the same. And the last one, the last fraction, what's missing is x minus 1. So on the top, on the bottom, you multiply by x minus 1. Don't forget to apply distributive property, and we can use now the least common denominator. Is going to be the denominator of the final answer. Okay. So 7 times x plus 7 times 1 plus 10x minus, be careful with the negative, negative 5 times x, negative 5x, negative 5 times negative 1, positive 5. Okay, so 7x plus 10x, 17x, minus 5x, 12x. And 7 plus 5, 12. Over x minus 1, x plus 1. Okay, this is the answer, but not yet the final answer. Always try to simplify, and only if it's not possible at all, you give up, not give up, you just finish and say, yeah, now I have the final answer. And that's pretty clear because I have 12 and 12. We can factor out 12, x plus 1, over x minus 1 times x plus 1. And of course we can cancel because x plus 1 divided by x plus 1 is 1. The final answer, now is the final answer, 12 over x minus 1. There's no way of simplifying any further. This is the last example. Now the challenge. 1/2 is 1/3 of it. What is it? It's a pretty short, simple riddle, and the answer is going to be a fraction. The pictures actually help us a lot. Look, this is 1/2. This is another half. This is another half, right? So 1/2 is 1/3 of it. So 1/2, if you get just 1/2, is going to be 1/3 of it. What is it? Yes, look, if you 1/2 is 1/3, you add 1/2 plus 1/2 plus 1/2, and you're going to have the answer. The answer is 3/2. 3/2, 1/2 of 3/2. 1/2 is 1/3 of 3/2. Okay, yeah, it looks a bit confusing, but it's a very nice, interesting riddle involving fractions. Thank you for watching. Again, answer the questions on MyLab Math, and I see you on the next meeting.